Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. My name is AMAR bin Muhammad ZULFANIS with the matrix number of A1929 and 26. And today we're going to be talking about ASHRAE Standard 100. So to start off, the standard is really about setting the criteria that will result in the conservation of energy resources, specifically in existing buildings. And unlike the standards you might see for new builds, this one is directed toward providing the procedures and programs that are essential to energy conserving operation, monitoring, and maintenance. It focuses on upgrading the building envelope and system efficiency, which is basically means improving the physical shell of the building to prevent any energy loss, while also making sure that mechanical systems like heating and cooling are operating at peak performance. This standard applies to existing buildings, portions of buildings, and complexes, also including the envelope and all energy systems, but it does exclude process systems. Now, a central figure here is the energy manager. This is a individual or a group or a function responsible for the energy consumption in the building, and their function include everything from policy management and engineering to the daily operations, maintenance, and accounting, etc. Moving on, under Standard 100, each building shall be classified by type according to what we call Form B, which you can see on the attached image on the right. And one of the most important things to remember is that energy management shall be given to the same emphasis as the management of any other cost or profit center is a business. When proposed energy management projects are evaluated, especially the ones with significant capital costs, a life cycle cost analysis shall be included. And for that, we usually refer to Chapter 36 of the 2003 ASHRAE Handbook, which titled Owning and Operating Costs, to guide that analysis. Okay, and to actually fund these investments, the standard identifies 5 general mechanisms. There's internal funds or direct allocation. We have debt financing with borrowed capital as an option. There's lease agreements, energy performance contracts, and lastly, utility or any other incentives. Next is the data collection and benchmarking. Now, the energy manager, they really have to understand how energy is used in the building to manage the usage and costs effectively, basically. They must analyze usage and electric demand data and establish and maintain any accounting system. This involves something called benchmarking. This is where we compare annual energy usage to that of similar buildings with similar usage and climates. And our data are actually pretty extensive. We look at the invoices from utilities and fuel suppliers, but also detailed printouts from time of use meters, and we even perform technical combustion efficiency, eddy current, and water quality tests. We record things like temperature and relative humidity, and we even conduct interviews with building owners, managers, and operators just to make sure that the data actually reflects what's happening on the ground. Now we see the metrics here. The data analyst relies on 2 primary markers, usually calculated over a 12-month period. First is the Energy Utilization Index, or EUI. This is the total energy used annually for all fuels per square meter of floor area. Second is the Cost Index, or CI, which is the total cost of energy used annually per square meter, both of which you can see the formula as attached. Now, when calculating this, the manager has to account for all fuels, something called pilferage and evaporation. And once all of that are calculated, the EUI and CI shall be compared with similar available data for buildings of the same type code from Form B we talked about in the previous slide, with similar occupancy and climate. The whole point is to identify if the building is performing better or worse than the average, basically. Okay, so effective management requires ongoing information. The energy manager shall maintain easily accessible records of energy used for at least the past 2 years. And they also have to handle communication, providing information to building occupants to give feedback on energy conservative efforts. The standard also requires an annual building logbook or a computer-based tracking system. Energy use must be reviewed on a frequent basis, or at least monthly, but daily if you have summaries available for building from a building EMS. This is to identify any unanticipated changes in the patterns. Okay, and technically speaking, each piece of equipment shall be maintained according to its manufacturer's instructions, and the system's manual shall be updated and maintained for each building. Usually, we follow the ASHRAE Guideline 0-2005. Next is the physical systems or major systems and building envelope. We look at the actual physical systems. For the building envelope, the standard is very specific. Exterior joints around the windows and door frames, between the wall and foundation, and even between the wall and the roof, they all have to be sealed. Any penetration for utility services through walls, floors, and roofs, those all must be caulked, gasketed, or weather stripped. And if you have broken windows or missing door sweeps, those shall be replaced immediately to prevent energy leakage. For the HVAC systems, they shall be equipped to provide automatic shutdown and setback control. And if the building has an energy management system, the start time for morning warm-up and pre-cooling shall be adjustable. Also, when you have multiple units like boilers and chillers, heating and cooling shall be maintained with the minimum capacity required for comfort. We also look at energy distribution systems like domestic hot water and lighting, all of which the standard 100 covers in great detail in the book. And lastly, it's important to understand how standard 100 connects to other professional resources. As I mentioned earlier, we used the 2003 ASHRAE handbook for owning and operating costs, but there also ASHRAE standard 105, which provides the standard method for measuring and expressing building energy performance. And if you're looking for details on the systems manual, you look at Informative Annex 0 of ASHRAE Guidelines 0-2005. For benchmarking data, we look at the external sources like DOE, BOMA, and the National Restaurant Association, among others. And locally here in Malaysia, these principles aligns with the MS or Malaysian Standard 1525, which is our own code of practice for energy efficiency in non-residential buildings. So in summary, ASHRAE 100 is a mandatory framework for management, data analysis, and technical maintenance, ensuring buildings remain resource efficient, and which is great for the environment and also business-wise. So that's all from me about Standard 100 by ASHRAE. Thank you.